Hi, so my name is Grace, and this is for my 431 extra credit. So first, for the file and the web server used, I used a website called vdisk.weibo.com, and it's an online drive based in China, and the file I'm using is a PDF file around 500 kilobytes, and it's gonna be downloaded from Safari. So the first thing that I looked at was the DNS latency. So first, I applied the DNS filter to Wireshark, and it looks like this. So when you apply the filter, it will look like this, and it will only show the lines with the DNS protocol. And then when you go into the packet header details, click on the domain name system where you can see the time under the request, and then when you right click on the time and apply it as a column. So for example, when you go here, you can apply it as a column, and here I named it DNS time, and then I sorted it. So we're gonna click into line 904 where the time took the longest, and it will look like this. So we're gonna go into line 904, and it's gonna be standard query 0 times D510. And the request, as you can see here, is gonna be in line 895. So when you go to 895, it'll tell you the transaction ID is 0xD510, and the response is in line 904. And the latency is 2.90553 seconds for this whole transaction. And there's also a graph right here that you can see that graphs. This is an IO graph for the DNS time. And you can also see the peak here if you look at it from the original graph. This peak represents line 895 to 904, and that represents this whole DNS transaction. And then next, the second thing that we looked at is the HTTP latency. So basic things when you first look at this, so we're gonna do the same thing that we did as we did in the DNS. So we're gonna apply the HTTP filter. And if you just go into the basic informations, go down all the way to here, it'll tell you, so go down all the way to here, and we will, again, like we did before, we're gonna find any line that pretty much indicates 200 OK at the end, and we're gonna expand the hypertext transfer protocol and apply. So we're gonna expand this line, and we're gonna go down to time since request, and for this one it's 0.54 seconds, and we're gonna apply it as a column again. And as you can see here, I've named this column HTTP time. If you can't see clearly, I named it HTTP time, and we're just gonna sort this column out, and the longest time that it took it's gonna be in line 873. So it will look like this after you sort it. And we're gonna go to line 873, if you can't see. Okay. So after we click into line 873, we're gonna find request. There is a request line in the protocol that details that we expended, and it's gonna tell you the request is at line 952, and the whole time it took would be 2.311226 seconds, and this is a IO graph of the HTTP latency response. Just to make sure that I didn't pick the wrong line for the analysis, I look at the file length, which was displayed to be this number, and it's around 520 kilobytes. So I knew that I had the right line. And then the last thing that we looked at was the TCP idle time. So again, we're gonna do the same thing that we did before and apply the TCP filter. The methodology I used for this one was that I used the Go, as I've described in here. I went to the first packet, and then I used the next packet in conversation in the Go toolbar, and it calculated the time difference. So it went from the first packet to number 4 in the conversation, and the idle time was 0.449566 seconds. I used the next packet in conversation again, and one interesting thing that I found was that it actually took me to this packet number 5, which was highlighted in red here, as you can see, and as you might not able to see very clearly on the screen, but it's right here. It's this line right here, and there's an RST in it. I looked this up, and I realized that this is a reset packet that you send. So I went from packet 425, and which was a reset packet, and then I used the next packet in the conversation again, and it went to the next packet in the conversation, and the time difference between that packet, which was line 10, and packet 5, the time difference was 0.440281 seconds. Comparing to the 0.449566 before, it was quite close. So this confirmed the idle time that I calculated from my methodology. And this concludes my presentation for this whole homework.